Welcome to an InterWEBview with Michael Snow, who is the founder and CEO of SnowPure. And Michael, we have your picture up here in the on the screen, and we'd like to have you tell us a little bit about your background, if you would, and then how you got to this position.
Oh, thank you, Bob, and I'm glad to share information on SnowPure and EDI. Yeah, a little bit about my background. I'm a chemical engineer, and currently I'm the owner of SnowPure Water Technologies, but in the past, and the way I became involved in EDI was to join Electrodeionization Inc. And Electrodeionization Inc. is a predecessor and one of the earliest EDI manufacturers in the world. And before that, I was head of membrane technology and membrane manufacturing at D-Cell, which became Osmonics D-Cell.
Yeah, so that goes back a way. You've the industry isn't that old, so it's a young industry, but you've got to represent one of the more experienced people in it.
Well, we used to make 35 different membranes when we were at D-Cell, and I remember when 8-inch modules were selling for $1,500. That was a different time.
Yeah, that is a different time, right? So, and you guys are located out in Orange County, California, there, out in the sun.
Yep, it's beautiful.
And tell us a little bit about your educational background.
Well, I'm a chemical engineer, as I said. I got my doctorate from MIT in chemical engineering, and I've been in the water industry since 1991, so it's been about 20 years.
Oh yeah, yeah. Well, let's go on to learn a little bit about SnowPure. Tell us about the buyout and so forth, and while we do that, I'm going to get onto your website.
Okay. Yeah, SnowPure is kind of the third, I'll say it's the third generation of this EDI venture. It started a long time ago with Harry O'Hare in 1977, who was playing with EDI, and started the company in 1979 as HOH Water Technologies. That became a public company and transitioned to a company called Electropure, which many people will recognize. And then in 2005, I had the opportunity, I joined the company in 1998, and then in 2005, I had the opportunity to do a management buyout. And so we are now a private company here based in California, but we're worldwide.
Yeah, that's interesting. In fact, you've got a rather large operation, do you not, in China?
Yeah, we do. We sell in 42 countries around the world. We've got service centers and sales offices in many regions of the world, including in China. I think our sales office in China has about 20 people, including technical service and customer service and marketing. So it's a pretty big operation. And then we did form an international distribution center in Hong Kong, basically because the market in Asia is the fastest growing that we see in the world.
Yeah, it certainly is. It's growing in all areas. It's all the semiconductor plants are being built there, and China's got twice as many coal-fired, almost 3 times as many coal-fired plants as the United States, who used to be the biggest coal plant operator in the world. So it's all there, isn't it?
It is. And you mentioned power plants. Power plants is certainly the biggest growing market for us. We do, of course, EDI is used in boiler water makeup for power plants, and I would say, I think at this point we have about 30 power plants in China. It could be more like 50, but at least 30 in China, and as well as all around the world. I know on our website it shows a couple, several in the U.S. and Texas and Oklahoma, for example. And we've got a lot of them at the Israeli Electric Company in Israel. But I would say we've got most of the power plants installations are in China.
Ah, that's interesting. And those Chinese plants are big. I mean, 600 megawatts is a standard size for them these days, and they are supercritical, all of them are supercritical boilers too. So you're talking high tech, not low tech, right?
It's true, and I will say, to give the Chinese credit, when it becomes critical, like in power plants and semiconductor, they like American technology, and they don't buy necessarily the Chinese made EDI. They buy American stuff.
And you would to tell us how that all works. Then you have a sales office in Shanghai. The modules are built where, and you mentioned you have the service capability there, but just go through that for China if you would. I think it'd be instructive.
Sure. Well, at this point, we are, we manufacture here. A lot of our patents are in the ion exchange membrane, and we manufacture the ion exchange membrane here in San Clemente, California. We've done all the design, engineering, and assembly out of our plant here. We are considering expanding our production capability, but we can talk about that at another time. Internationally, we have a sales office and distribution center in Japan and service center. We have the same thing in Korea. We have one in India that covers India and Pakistan. But I think by far our largest is in China. And in China, we have 5 regional salespeople, and we've got the capability to service modules in China.
And what is involved in the service of the modules there?
Well, mostly, let me back up and say one of the things that we preach as part of our training and our education is pretreatment. So just like with reverse osmosis, the key to making an RO system work well and work for a long time without maintenance is its pretreatment. And so for an EDI to operate very well and for a long time without any kind of service or cleaning, the pretreatment to it is critical. And on our website, we do have technical information about what we require, what we recommend for pretreatment.
Maybe we can just go to that for a second there. Where would we find that then on the site?
Well, up the top where the blue buttons are, that's a simple click. If people click on that, you send us an email and we can send you back a technical manual.
Oh, okay.
But under downloads, I think is probably the best place.
Okay.
And under
EDI technical, or?
I'm looking to see where our technical manual is. Probably under SnowPure downloads.
Okay, and then I'm looking at the company brochure concept. Over on the left-hand side, there is a EDI technical.
Look at the EDI technical.
I think I actually saw that. Yeah, that's what I was looking at before. Yeah.
So in the very top section, our OEM engineering manual, the complete manual is there, and we share that because of our belief in education and training and getting knowledge out to our customers. But the summary of our EDI feed water specifications is also there. And what we do is, of course, we've got a broad range of acceptable levels of all the incoming water feeding the EDI, but we do have some, basically to get the best optimum performance, we've got a recommended level as well. So that's how we do our specifications. But to answer your question, if you get the feed water right, you can run an EDI for a year without doing any kind of maintenance on it. They tend to be biostatic, so pharmaceutical companies like them. And really then the only maintenance, might be an occasional, checking and maybe an occasional acid cleaning, something like that.
Now, and these are the cleaning chemicals that would be used to clean the EDI?
Yeah, and again, I would say we put these there just in case, and a lot of people had earlier experience with scaling and fouling of modules. But if you follow our feed water specifications, you really shouldn't need these cleaning chemicals. One of the common things that is hindered or that has plagued EDI in the past is scaling. And we'll talk a little bit later about some of the advantages that we have, but we've got a concentrate and electrode system that really does prevent scaling. We rarely see scaling in our systems. Part of that is the design of our Electropure EDI modules, but part of it is getting our customers to get the right pretreatment and to maintain the pretreatment and to get the right water feeding the EDI.
Well, good. I think that answers that question. We can go on to the other applications, but why don't we maybe go to products first, so you can tell us a little bit about the, about the design of the EDI and why the maintenance is low.
Okay.
So would that be, let's see, we would go down to the EDI here, or
I think so. Try that.
Yeah. Yep, there we go.
Okay. On the left, there is an EDI product family brochure, and that probably is the best place to start.
Okay, should we click on that then?
Yeah, click on that for now.
Right.
Now that's a PDF that anybody can download, but what it shows is the wide range of flows. Down the left are the flows, and they range.
I got to go back again here. Sorry. Stop my video and do that. And let's see. I need to go back into the system here. Exit full screen. Pardon me. Operator error. Okay, we're back. Take looking at it here. Go. Sorry.
No, go ahead.
Okay, so now let's see. Now we need to go back to the brochure, right?
Right.
We jumped out of the brochure. Okay.
If you can maximize that, or just
that's what
down.
I was trying to do, and so I think what I'm going to have to do is move this other screen down a little bit, so I'm going to get that out of the way here. Okay, now I can do it. Now we'll maximize it. Good. Okay.
Anyway, this shows the down the left side is the wide range of flows that you can get from our modules, and it ranges from 10 liters per hour, very small, cute little EDI for laboratory use, up to our largest product line, the EXL, which goes up to 8 cubic meters per hour, which is about 35 gallons a minute. And then you can see the different applications across the top. There's a set of products for laboratory, for industrial and power generation. And the new product is the EXL product. The EXL product is, there's a 600 and a 700, and we designed those. The 700 is really designed for power plants, and it's designed for power plants, and the biggest demand is in China. So we made the introduction of that product a couple of years ago in China, and it's been very successful. The EXL 600 is designed to be a replacement module for some of our competitors' modules. It's we've chosen the dimensions, the exterior dimensions, to be sort of in industry standards now, but internally we have the Electropure technology. You and I can talk about that in a minute, the things that make Electropure unique. But we also have a line, you can see the next column is sanitary and pharmaceutical, and we have a line of high temperature stable modules that go up to about 2 cubic meters per hour, about 10 gallons a minute.
And they are more heat-resistant membrane. Is that the?
Yeah, and resin, and they're designed, so all the plastics they're designed to be basically periodically heat sanitized up to 80 degrees C.
What kind of applications would you require those higher temperatures?
In this case, it's predominantly pharmaceutical. So pharmaceuticals are moving away from using chemical sanitizers or peroxide peracetic acid toward doing heat sanitization.
So they would try to get up to sterilization type temperatures?
Yeah. And usually, bacteria are killed mostly around 65 C. They're all killed by 75, so a lot of companies will go up to 80 degrees just to make sure the kill is there. And the ROs have been heat sanitizable for probably 15 years. We introduced this product, I think, in 2004.
Okay. So let's now maybe we can go and talk about the features a little bit there then of your unique modules and things.
Yeah. So I think if you go to the top to products.
Okay. And then we can go to EDI or EDI modules.
Yeah. Or maybe head over to technical, I think.
Right. Technical benefits.
Technical benefits. Let's talk about that.
Okay. The technical support.
Go to the top, the next one down on the menu.
Okay. Whoop.
There you go. Up.
Oh, the technical benefits. Okay. Technical projections, technical benefits. Okay, there we go.
Beautiful.
Yeah, right, okay.
I would say there are three things that make Electropure EDI different from anybody else's EDI. The first one we call thin cell technology. This is something that that was in our patent a long time ago, our original patent from Harry O'Hare was written in 1981, so it's very old. But he knew the virtues of thin cell technology. Other people in the industry have used thin cells in the past, but have moved away from it to save money. The thin cell technology, though, is very good at getting the highest quality water out the EDI and to minimizing the use of electrical power. So that's one thing. I think we're the only people in the world that use thin cell technology today. The next one is we call thin concentrate technology. Our experience, in fact, even the original patent in 1981 contemplated the use of a filled cell concentrate, but a filled cell concentrate where you would put ion exchange material in the concentrate it's got a major problem, and that is that all the foulants that you're removing through the EDI end up in that concentrate, and over time that concentrate can become fouled and loses its effectiveness. So our strategy since the late 80s has been to use a very thin inert screen, and the thin inert screen gives you good mass transfer and really minimizes the potential for scaling. So, and that combined, we balance the resins and the membrane properties to make the concentrate a little bit acidic, and that combined with good mass transfer means that we rarely see any EDI that comes back with scaling. And the third area is we call it a non-fouling electrode, and the non-fouling electrode basically is a system that we've used also for a long time, which prevents the flows in the electrodes from going high in pH, and by doing that, we avoid having any kind of scaling as well. So we never get into a scaling regime.
Now, how does this translate then in terms of the life of your modules versus obviously there's the spiral wound technology, and you might just kind of contrast your design to the others and how these three features translate into either less maintenance, longer life, whatever.
Sure. Well, I would say that two things really limit the lifetime of EDI modules. Think of EDI modules as basically being plastic and resin. And so the things that harm plastic and resin are the things that our customers need to avoid, and that's what we teach. So one of the things is oxidizing agents. Now, none of these things here, I think avoiding oxidizing agents like ozone and chlorine are keys for everybody's EDI. But when people have good clean water and they don't have oxidizing agents, the longest life we have seen is about 15 years.
That's pretty long, yeah.
Pretty long. And the 15-year lifetimes, they're somewhat unique in that the water feeding them is so good, and the customers know exactly how to do that, but you can get 15 years out of them. I would say we warranty the modules and we expect at least a 3-year life. Most of our customers around the world expect 4 to 5 years of life, but you can certainly get longer. Now, one of the things, back to your question, one of the things that limits the lifetime is when you have to come in and do a chemical cleaning, it will necessarily shorten the lifetime a little bit.
Sure.
So these three things that we do in our design to limit scaling and limit fouling and limit the production of chlorine within the module, basically their key is to limit then the maintenance and the scaling in the module, which limits chemical usage and having to send people out and do services on modules. So if you can avoid doing chemical cleanings, you will extend the life of your module.
That certainly makes sense. We might then move on to, unless there's anything else you'd like to add here, we can move on to these other applications.
Sure.
We've talked power generation. Why don't we talk the pharmaceutical industry? You've already told us a little bit about the higher temperature resistant modules, but tell us a little bit more about the general application and your success there.
Yeah, I would say the interesting thing about pharmaceutical is that they were really the first adopters of EDI, and the advantages for a pharmaceutical company who's trying to meet USP or EP or JP standards for either process water or for water for injection, is that they need a system that they can control. And with ion exchange resin, they don't have control over the resin, and they don't like having chemicals in their plant. So they're really the first adopters of EDI. So most pharmaceuticals today, in fact, I would say probably 80%, they don't use 2-pass RO, they use RO and EDI. So that was really one of the first markets for EDI, and we've got, actually we're almost on serial number 10,000. So I'm going to say we've built about 9,000 modules in the company's life, and I'm going to say at least half of those have gone into the pharmaceutical industry.
Yeah, that's a pretty impressive number of installations.
Most of these installations are relatively on the small side, compared to power plants. So mostly they're 5, 10, and 20 gallon a minute type systems, 1, 2, or 4 cubic meters per hour, and there are even some smaller ones. But that is pretty typical. Although, as you know, China does everything big, and in China, they're looking for much bigger pharmaceutical systems.
That's interesting. Well, it sounds like you're strategically placed in just the right area. Let's talk about another area in China that's big right now, which is semiconductor. They're building semiconductor plants faster than anybody. What are you doing there?
Well, actually, semiconductor is interesting because, of course, there are a few new fabs that are being built, but the fabs are sort of few and far between, and there's a lot of competition for their water treatment. What is a growing market, though, if you look at the picture on the right, is solar cells.
Oh, yeah, right.
So solar cells both in the U.S., down in Brazil, all through Europe, as well as in China and Japan and Thailand, solar cell manufacturing is booming. And solar cells are, in fact, semiconductors, and they need ultrapure water, although it's not as critical as in an Intel plant.
Yeah, this certainly is a very big market. We do track all those solar photovoltaic projects around the world, and of course the manufacturing is part of it, but it certainly is looks to be the wave of the future. There's no more efficient way to take advantage of the sun's energy than directly like this, that's for sure.
Yeah, that's where we see the growth market is there. Of course, we were down in Singapore for International Water Week, and certainly Singapore is a leader in semiconductor, and I think in Singapore there are 4 fabs, and I believe all 4 fabs use EDI.
That's interesting. So that's one thing. We were trying to determine the penetration rate and around the world of EDI versus alternatives, and you mentioned that the pharmaceutical industry was an early adopter. Would you say for ultrapure water, almost every pharmaceutical plant is using EDI?
I'll beg a little bit of ignorance. I know it's at least 50%. It might be as high as 80%. There's still some pharmaceuticals out there around the world that use ion exchange resin or even 2-pass RO, but most of them, when they do a refurbishment or build something new, will use EDI. Semiconductor, I think it's probably almost entirely using EDI.
Almost entirely, okay.
But of course, EDI is only one of maybe 15 unit operations to get the water they need.
Right, that's a good point. And then the new thing that's popped up is the reuse too, right?
Yes.
So
actually, it's not really shown on our website, but I do want to let people know that is something that SnowPure does. We make a number of proprietary EDIs for customers and for specialty process applications. In process, for example, recycling and recovery of hydrofluoric acid, for separation of some organic acids. So EDI is not just used for water, although that is the predominant use in the world.
Well, that brings up another subject then. In our reporting up on the website, we reported on this Nalco argon license where it will be used. You mentioned organics. It's going to be used for biofuels, and I assume for the cellulosic ethanol type process. But we've been following that, we know that there's a two-stage acid process that's pretty costly. If there's some way to separate out the lignins, with EDI rather than with an acid process, that would be pretty cost-effective. But you're saying you've had some experience in this whole area of the organics.
Yes.
Do you see that as an opportunity yourselves to get into either this or to get into the desalination with the EDI?
Probably not desalination. That's not really the niche I think that EDI fits, but I certainly think the process applications work. Back to my background at desal. At desal, we had developed a lot of applications, or helped our customers develop a lot of applications that were non-pure water processes, so food treatment and waste treatment and things like that. And so, these are applications that need a leader, need a cheerleader. But a lot of companies, it's critical for them. Companies like Archer Daniels Midland,
right,
who treat lots and lots of fluids and are looking for new technologies. So we're always willing and able to work with customers like that. We've got a number of systems in fact, in solar plants to help recycle internal water, because that's certainly a trend of the future.
Yeah, it looks like you're on the cutting edge of a lot of this application. Of course, with your chemical engineering background and experience with the membranes and desal and so forth, you obviously have some capabilities that are unique there. Let's talk a little bit about the OE.
Just one thing I wanted to say, and that was one of my mentors was Don Bray.
Oh, okay.
And is a nice gentleman who passed away this year, unfortunately. But one of the things that he taught me as we worked to push our membrane technology back then into some pretty difficult applications. When you do that, one of the benefits is you learn where the failure points are, and you can push those out. And so as you're pushing the limits of what the technology can do, you can reapply what you've learned back to your primary product and continue to make your primary product better.
Yeah, that's an interesting point, and I think one well taken. Now, you talked about the OEM relationships, and of course you featured that right up on the website. Tell us again, just go over that a little bit more in detail.
Okay, well, so where we are in the marketplace, SnowPure builds, designs, and sells only the technology, only the modules. We don't build systems, and our customers are all OEM pure water system integrators, and so our job is to help them to build and sell systems and to be successful at that. And because of that, we can claim to be one of the only EDI companies that doesn't compete with our customers.
That makes sense. Now, what happens, though, when it comes time to replace a module, after this 3 years to 5 years to 15 years?
Well, that's also the responsibility of our OEM customers. Our policy is we don't sell to end users, and so what we do is, even if end users contact our customer service, we will redirect them back to the customer that sold them the system in the first place. Or if they're looking for more competitive or different options, we'll give them references to 2 or 3 of our customers who are in the country or in the region.
Yeah, what this allows you to do then as a company to focus on your R&D and your product quality and channel your efforts there and make better products and more reliable products, et cetera, right?
That's right, and it allows us to leverage it, because we can't be in country, and we sell to 42 countries, at least given who we are.
Sure.
We train our OEMs to do a good job of servicing, and that's part of how they make their living. They build the capital equipment, and then part of the way they make their money is to get long-term service contracts with their customers. So we try to enable our customers to do that.
And I think that brings us to the last point, which is the education and training. Who are you educating and training? Is it the OEMs? Is it the end users? And how do you do it?
Yeah, thank you for mentioning that. That's something that's very important to SnowPure. Because EDI is a relatively new technology, we know that our customer success is greater when their knowledge is greater. So education and training is a priority for us. Mostly we train and educate our OEM customers, their engineers, their salespeople, so that they can design the best systems, and they can not oversell them, but they can educate their customers. And mostly we do that by a free training that we offer here at SnowPure in San Clemente, California. For anybody who's listening who's in Russia in the wintertime, it's a nice place to visit.
Right.
But we also, for our in regions where we have a sales office and a service center, our distributors are also trained in training the customers locally there. And occasionally, if it is a big company that we're selling to, we can come out and visit that company and do on-site training and get a bigger group. But we do tailor the training to individual customers, because each one of our customers does have different levels of knowledge already, and they also have, of course, different markets and different focuses. And so that's really that's very important to us. Again, this priority is to make sure that our customers have the knowledge to do a good job.
And one more question on the customers. Say I'm an OEM, small OEM that's just getting into the business. Are you dealing on any kind of an exclusive basis, or is the door open to any OEM that can meet some of your technical qualifications? How do you is there a selectivity, or just how do you select your customers?
Well, the answer is, for our distributors, we do have some exclusive regions for them so that we protect their territories. But in terms of our actual customers, the OEM customers, we're open to everybody, as you say, who qualifies. Qualifying, we want people who build systems. Ideally, they're already in ultrapure water markets somehow. So they build systems. They've got some capability already, and they're willing to be educated and go through our training. And then what we find is that we spend a lot of time with our customers going through their first system in the design. We have a P&ID review service where they can send us their design, and we can make sure that it's going to be optimum, make sure they didn't forget anything, try to troubleshoot in advance. And I would say for the first year, we spend a lot of time on the phone and by email with our new customers to help them. And after that, it becomes a case where they call us when they have unique situations. But that's what I found is the most likely thing to happen. Anyway, we are open to all OEM customers,
including a number of customers in Europe, and that's why you're going to be at Amsterdam there for the Aquatech show, I see.
Exactly. That's actually the two biggest shows that we have found to be valuable, where we see the most customers, are in Amsterdam every 2 years, and in China now every year.
Interesting.
So fantastic markets.
Yeah, the China in China every year is for the Aquatech China, or is that
yes.
for Aquatech China?
Aquatech China.
Yeah, that's interesting. And I see Singapore week had about 700 exhibitors there, so that was no small conference, was it? Or exhibition, was it?
Right. Now, Singapore was big, covers all of the ASEAN countries. Aquatech now also shows in India, and we were showing in India at the Aquatech this year. It was in Mumbai.
Oh, did you? Huh? Okay. So there's a lot of big coal-fired power plants that we're tracking in India right now. So I imagine that's a good opportunity for you.
Well, it's interesting. In India and Japan, we find that the engineering companies that design those are very, very conservative, and so in both countries, I don't think there's a single EDI installation in power.
Really?
I'm going to guess that in 5 years there will be, but because of their conservative nature, they're going slow. They rely in India mostly on, not even so much on RO technology, but mostly just on ion exchange.
Huh.
technology. In Japan, they certainly have lots of good water treatment, but they've not ventured into EDI yet. And I think certainly with the typhoon disaster, the tidal wave disaster, tsunami, they're going to probably remain to be conservative about their water treatment for another decade.
But that brings up one last point. I didn't mean to go on, but I think it's very interesting. What do you think the potential is for EDI? In the power industry, it could be as low as you mentioned, possibly a penetration rate of 15%. Our rough back of the thumb calculation showed that with all these old power plants that were on the road, maybe it's only 6 or 10%. So you've got somewhere between 85 and 95% of the plants out there that are not operating with EDI. Is there an economic justification for, even say your plant life's another 10 or 15 years, to go in and put the EDI in?
Well, I'm going to say yes. Once people understand, if you have an all-membrane system, the cost savings, and the current cost that they may take for granted, if you've got an ion exchange resin system, you're bringing in chemicals, you've got hazardous waste, you're generating, you've got hazards for your workers, you've got the cost of the chemicals, and to be able to tear that out and to put in an RO, maybe Liquicell EDI system, which is going to be continuous operating, and you eliminate the use of chemicals, and you eliminate the need for for training and hazardous waste and hazmat and all of that, is certainly a major trend. So the issue is it's a big CapEx expenditure, but the benefit is you've got much better safety, much better environmental, and a much better operating cost.
Now let's talk a little bit about the environmental. We do a lot of InterWEBviews with the utility industry, and we were interviewing one of the experts at CH2M Hill who had just done a study of one of the Wisconsin plants and pronounced that no matter what they did, they weren't going to meet the Great Lakes Initiative for water quality. And he said one of the things they found was that in the sulfuric acid that the plant was using, there were enough heavy metals that somehow those were getting into the wastewater and by themselves were disqualifying the plant from meeting these, few parts per billion of these very toxic metals that are in that initiative. So I guess I'm a little confused as to if you're using an acid wash for your ion exchange, how does it get into the wastewater? Does it not go into some sort of a special treatment system?
Well, yeah, it does, but mostly so when a company will use, say, sulfuric and caustic to regenerate their ion exchange, either those heavy metals are going onto the ion exchange resins, and they'll eventually come off and go down to the drain, or when the waste acid and caustic is neutralized, they basically make a salt solution, but it has all those heavy metals in it as well, and they have to discharge that. So the trend will be to make and use higher and higher purity sulfuric, for example, which will do nothing but drive up the cost of the chemicals. So both on the waste end as well as on the cost end,
right? Those
are both drivers for switching to a chemical-free system.
Yeah. So you have the difficulty of meeting the environmental regulations, and you got the cost of meeting them as well. So you've got a couple reasons.
Right.
Well, Michael, you've been a fountain of information. I think it's been very instructive for me, and I appreciate your spending the time. And we will look forward to interviewing you again in the future.
Well, I appreciate what McElvain does for the market, and I appreciate the time to be talking with you.
And thanks again. Bye now.
Bye-bye.